Hi everyone, welcome back to our PLC programming full course. In the previous video, we explored the S7-300 PLC hardware, covering essential components like the CPU, input and output modules, and how they interact with the PLC. Now, it's time to move on to the exciting part: PLC programming. Imagine you're working in a factory, and you need to control an electric motor. When you press the start button, the motor runs. When you press the stop button, the motor stops. How can we achieve this using PLC programming? Siemens provides two powerful and user-friendly software platforms for programming the S7-300 PLC. 1. SIMATIC Manager. Classic and widely used in industrial automation. 2. TIA Portal. Modern and more integrated. For this course, we'll start with SIMATIC Manager, as it provides a strong foundation for PLC programming. The first step is to create a new project in SIMATIC Manager program. Let's do it together. Go to the toolbar and click New, or select New from the File menu. As you can see, in this window, I can assign a name and choose a save location. In the name field, I'll type YouTube Tutorial. But you can enter any name you prefer. I don't need to change the storage location, so I'll leave it as it is. Now, I'll click OK to proceed. Great! Our project is successfully created, and we're ready for the next step. Once the project is created, the next step is to insert a station or program from the Insert menu. Now, from the Insert menu, I'll select 300 station. Why am I choosing the 300 station and not another one? It's simple because I'm working with an S7-300 PLC. As soon as I insert the station, the program guides me to the hardware configuration. Until I complete this step, I won't be able to move on to the programming section. But here's an important question. What if I don't want to configure the hardware because I'm not working with real hardware? Let's see what happens if we delete the inserted station and take a different approach. This time, instead of selecting Insert Station, I'll go to the Insert menu, select Program, and choose S7 Program. As you can see, in this case, I can go straight to the programming section without configuring any hardware. However, I prefer to insert a station because I want to work with a proper hardware setup. So, let's go back, select a station again, and continue with the hardware configuration. In Lessons 1 and 2, I explained the S7-300 hardware in detail. If you have any questions, I recommend watching those videos first. Now, let's take a look at this section of the hardware configuration window. This is called the catalog. From here, I'll select SIMATIC 300. As you can see, several folders appear, each representing a different type of hardware component. SM, Input and Output Modules. Rack, the rack itself. PS, Power Supply. IM, Interface Module. FM, Function Module. CPU, the CPU. CP, Communication Processor. The first step in hardware configuration is inserting a rack. In the catalog, I'll select the rack and place it in the configuration area by either clicking on it or using drag and drop. Next, I'll add the required modules power supply, CPU, input-output modules, and any necessary communication or function modules exactly as they are in the real hardware setup. Let's get started. Now that I've inserted the rack, the next step is to add the power supply. As I mentioned earlier, slot 1 is designated for the power supply. However, inserting it is optional. You can leave this slot empty if you prefer. In my real hardware setup, I'm using a 2-amp power supply, so I'll select it from the PS folder. As you can see, when I click on the PS module, the program highlights slot 1 in green. This indicates where the power supply should be inserted. Now, I'll click on PS307, 2-amp, and as you can see, the power supply is now placed in slot 1. After inserting the power supply, the next step is to add the CPU. My CPU model is CPU 312C, so I need to select the correct one from the catalog. When I open the 312C folder, you can see several 312 CPUs, each with a different order number. To ensure I select the correct module, I need to check the order number written on my real CPU. In my case, the order number is 6E-S7-312, 5B-F040-AB0. Now, when I select the CPU module, the program highlights slot 2 in green. This indicates that the CPU must be placed in slot 2. Let's test something. What happens if I try to insert the CPU into slot 6 instead of slot 2? As you can see, the program alerts me that the CPU cannot be placed in this slot. So, I'll select slot 2 and insert the CPU by clicking on it. Now, the CPU is correctly placed in slot 2. The CPU I inserted is a compact model, and as you can see here, it has 10 digital inputs and 6 digital outputs built in. Because of this, for this video, I don't need to add any additional input or output modules. If you remember from the previous video, we discussed that the Siemens S7-300 PLC has 2 types of CPUs, compact and modular. The CPU I initially inserted was a compact type, which matches my real hardware. However, I want to delete this CPU and select a modular CPU to practice with. I will select a 312 modular CPU. In this case, the order number is not important because I am just testing. For example, I'll choose this one and insert it. As you can see, the CPU has been inserted. Unlike the previous compact CPU, this modular CPU does not have built-in inputs and outputs. Now, I need to insert signal modules to use this CPU in our project. Let's select the signal module. First, I will insert a digital input module. If I open the digital input folder, you can see different types of input modules with varying numbers of inputs and voltage ratings. If I were working with real hardware, I would select the exact module based on its order number. However, since this is just for testing, I will select any available module. As you can see, when I try to insert the signal module, the program highlights slots 4 to 11, indicating that I can insert the module into any of these slots. Now, I will select slot 4, click on one of the modules, and insert it. Next, we need a digital output module to control actuators. I will open the digital output folder, select one of the available modules, and insert it into slot 5. In the hardware configuration, I inserted the input module in slot 4 and the output module in slot 5. This is important because in the real hardware, I must follow the same configuration. That means the digital input module should be inserted in slot 4 and the output module should be inserted in slot 5 for the system to work correctly. Now, I have a question for you. Should I insert the input module first and then the output module? Or can I configure the output module before the input module? Let me know your thoughts in the comments. When using a modular CPU, you must insert input and output modules according to the project requirements. When using a compact CPU, if the built-in inputs and outputs are sufficient for the project, you don't need to add extra modules. However, if the compact CPU does not have enough inputs or outputs, you will need to add additional signal modules. I hope I have been able to clearly explain the concept of these two types of CPUs and how to use them. Now, I will delete these modules and reinsert the previous CPU to continue our discussion. After inserting the CPU into its slot, you can click on it to open its properties. As you can see, I've clicked on the CPU, and this window has appeared. It contains several tabs such as General, Startup, Clock Memory, and more. I'll explain each of these as we need them in our program. If I select the rack, this section of the window displays important details about the installed modules, including which module is inserted in each slot, information about each module, such as its order number and address. For example, here you can see the CPU's order number, its firmware version, MPI address, and input-output addresses. It's important to understand that when using an input or output in your program, you must use the correct address. This is because when the PLC executes the program, it checks the status of the specified address. By default, input addresses start from I124, and output addresses start from Q124. PLC input and output addresses are in binary format, so they must be referenced correctly in the program to ensure proper operation. It's important to understand that when you use an input or output in your program, you must use the correct address. This is because when the PLC executes the program, it checks the status of the specified address. If I want to modify these addresses, I need to click on D, I10, and D06 in slot 2 to open its properties. As you can see, I clicked on it, and this window appeared. In the General tab, I can add a comment, rename the inputs and outputs for easier identification. In the Addresses tab, I can change the input and output addresses. To do this, I need to uncheck the System Default box, which allows me to modify the addresses manually. I'll change both the input and output addresses to 0. Now, as you can see, the input and output addresses have been successfully updated to I0.0 and Q0.0. We have completed the necessary hardware configuration for this video. However, in the next video, we will cover more details and explore additional settings. To finalize the hardware configuration, click Save and Compile from the toolbar. Now, we're ready to move on to the programming section. Now, as you can see, the S7 program is available. To start programming, open the OB1 block from the S7 program folder. OB1. Organization Block 1 is the main cyclic execution block in Siemens S7-300 PLCs. It serves as the central execution loop, continuously processing logic while the PLC is in run mode. SIMATIC Manager supports different types of programming languages, including ladder logic, a graphical representation of logic, resembling electrical control diagrams. FBD, function block diagram, a block-based logic programming method. STL, statement list, a low-level textual programming language. SCL, structured control language, a high-level programming language similar to C. For beginners, ladder logic LAD is the best choice because 1. It resembles electrical diagrams, making it easy for electricians and engineers to understand. 2. It offers a visual representation, simplifying debugging and troubleshooting. 3. It is widely used in industry, due to its simplicity and readability. Since ladder is the easiest to start with, I'll begin by teaching ladder logic first. We'll explore FBD, STL, and SCL for advanced programming. When you open the OB1 block for the first time, the OB1 Properties window appears. In this window, you can select the programming language and define a name for the block. In this Properties window, I don't need to change anything. By default, the ladder logic LAD language is selected, so I will continue using it by clicking the OK button. Now, as you can see, the OB1 window has opened, and we are ready to start programming. Here are the program elements for ladder logic. We can choose any required element from this section, such as bit logic, comparators, converters, timers, counters, and more. By the end of this tutorial series, we will work with all of these elements. In this section of the window, information about the selected element is displayed. For example, if I select an element from the bit logic folder, you can see that it is labeled as a normally open contact. This part is the variable declaration table, which contains parameters and local variables for the block. And here is the most important part, the program editor. This is where we write the program inside networks. Before starting PLC programming, it is essential to understand how addresses are assigned to inputs, outputs, and memory elements. Proper addressing ensures accurate communication between the program and the hardware. PLC addressing is based on the binary system. What is the binary system? The binary system is a number system that uses only two digits, 0 and 1. It is the fundamental language of computers, digital electronics, and PLCs, programmable logic controllers. Each digit in the binary system is called a bit, short for binary digit. Bits are the smallest units of data in digital systems. Here's how binary data is structured. 1 bit is the smallest unit of data. It can be either 0 or 1. 8 bits make 1 byte. 2 bytes make 1 word. These units are important in programming and PLCs. PLCs use the binary system to process data, control inputs and outputs, and execute programs efficiently. In Siemens, S7-300 PLCs, inputs, outputs, and memory addresses follow a structured format. Inputs are designated with the prefix I. For example, I0.0, I1.2. Outputs are designated with the prefix Q. For example, Q0.0, Q2.1. Memory bits are designated with the prefix M. For example, M0.0, M3.5. Addressing format. Each address follows the XY format, where X represents the byte number. As you may recall, in the hardware configuration, we changed this address from 124 to 0. Y represents the bit position within that byte, ranging from 0 to 7. If we have a 16-input digital module, the 16 inputs are divided into 2 bytes, byte 0 and byte 1. The addresses must be assigned correctly based on the hardware configuration. Assuming the start address is 0, byte 0, first 8 inputs, I0.0, first input, I0.1, second input, I0.7, eighth last input in byte 0, byte 1, next 8 inputs, I1.0, ninth input, I1.1, 10th input, I1.7, 16th last input in byte 1. This pattern continues for additional input modules. Understanding this addressing method is crucial for writing accurate and efficient PLC programs. In the next steps, we will apply this knowledge to real-world programming scenarios. Now that everything is set up, we are ready to continue our project. In this video, we covered creating a new project in SIMATIC Manager, performing hardware configuration for the PLC, introducing OB1 organization, Block 1, the main execution block in the program. In the next video, I will introduce bit logic instructions and demonstrate how to write a ladder logic program to control a motor. Stay tuned.